Okay, so I have the pleasure to start this conversation. It's meant to be a conversation, so don't hesitate to interrupt me or not if you disagree with what we're saying, especially if what I'm saying. So I'm Alex Grandfort. I'm a professor at Télécom Paris. So I teach machine learning, statistics, optimization. So I would say it's more the aspect of data science which is related to the predictive part. So I'm also one of the developers of scikit-learn. And so just to basically discuss a bit the topic of the roundtable, propose to take 3 minutes to tell you what we teach in Télécom Paris and the types of students we have, and basically the students that you get with a resume saying data scientists, what they do and what they learn, and what are the different types of students that we produce. So yeah, we produce students, data scientists. I'm the data provider, the data scientist provider. So I would say today in Télécom Paris Tech we have about 80 students that follow what we call the data science track. So which is basically what the amount of students that were doing finance 15 years ago. That's basically the same ratio of people, and which means that we have a very vast audience, people coming with more like a computer science background, so hackers, and people who are coming from a very stats and math background, which are basically interested in learning theory and apply this to data problems. Which basically also orients the types of teaching we do. We have the more computer science part of the classes and the more which is the mathy aspect of it. And basically this is something that is done over 2 years, basically built on fundamental disciplines from statistics and algorithms. And I would say a big difference in these types of training is that we try to do half part-time hands-on sessions, which means that we give them challenges, we give them real data to look at, assignments where we give them CSV file to see what they can do with it. And I think it's a big part of the training to basically put them in real situations. It doesn't work with all students, but I would say the curious one, it works like amazingly well. Yeah, so I don't know if there's any. I'll probably come back to the rest if I've got questions. Or thank you.
Okay, so I'm Irène Balmès. I'm here to represent more recent data scientists. Personally, I transitioned from an academic background in astrophysics about a year ago to data science. So I never got the chance to have a proper data science class, but I have a more hands-on experience. I would say basically that when you have a lot of PhD experience and hands-on experience, particularly in fields like physics and astrophysics and biology, where you use a lot of statistics and a lot of coding, transitioning to data science is not so difficult. With all the MOOCs and the available documentation online, you have an advantage of having more hands-on experience and less theoretical knowledge, but the theoretical knowledge you can pick up by yourself, mostly, I would say. So I don't know if I have anything else to add, or. Oh yeah, I very recently was in a competition with a very very pretentious name of the best French data scientist, where I happened to be 5th, and I was the first woman. And I'm in a very small company, which is called Kinaps. Thank you.
So you're the best women data scientists.
Yeah, that's what my company has been advertising ever since. So yeah, even when you're not coming from a classical background of data science, you can manage to do something good in competitions and showcase yourself.
Okay, so I'll try to start to present. So I'm François Sausset. I'm working in Saint-Gobain since more than 4.5 years. So we are in a team of more than 10 data scientists. We are growing, and I can speak quickly about the profile of the people that came and that will come. And so I will just, I have only a few things to add to the Erin talk, because I'm in line with her, is that fields like yes, computational biology or astronomy or statistical physics are very good fields to become data scientists, and they are not the only ones for sure, but they are good ones. And for instance, in our team, we have a mix of PhD people and people that have a master's degree, and it's nice to have a mix of people. And also, it's nice to have different profiles. So to have people that are far from computer science, but have PhD and have different point of view, like astronomy or biology or statistical physics is good. And people with more mathematical skills is great too. A mix, so it's nice for day-to-day operation. It's nice thing. And yes, perhaps to also add something from a business point of view, a data scientist in the daily life in a company is to have a knowledge of the business, to be able to talk to business people, to understand them, and be able that they are understanding you. So, but it's something that you don't know anything when you come first, but you will learn very fast. So don't bother about that. It will be easy. You have also the math background that is important, but not the most important. And from my point of view, hacking skills or hacking mindset is the most important thing. Be open to try a lot of things, learn a lot of things, tools, languages, so that's something that I think is the most important. So I have nothing more to add. If you have any questions,
I will start with a first question. What about Python? Do you train your students using specifically Python or other languages and tools? And do you expect your data scientists to use Python as a primary language in your company?
So I would say now all the data classes are done in Python. I'm a bit responsible for this. I would say R was the main language used by statisticians before I arrived at the school, and now basically everything is done in Python, which is also because also it facilitates communications with the more computer science department. I'm more in the math and statistics research groups, so that helps communications. People doing databases, they have still a little bias towards Java, but I'm working on it. And so clearly in terms of skills, and especially, now, people in Telecom Paris were coming from what you call classe préparatoire, sorry for the non-French people that don't know how these things work, but they typically arrive these days knowing Python because that's the language they learn at this level. So that helps a lot because they have the basics of algorithms very early. So,
Irene, how did you discover Python?
Well, like any classical astrophysicist, I started with IDL, which is a terrible ID, because no one uses IDL except astrophysicists. So when you want to leave astrophysics, it's very difficult. And I think Python is very good for that because it's a language that's used everywhere. So you can absolutely use it in academic research to do whatever you're doing with, and you can apply it afterwards elsewhere if you want to leave academics and go to another place. So mostly on a day-to-day basis now at Kinaps I'm using Python. There's a lot of people coding in R as well because it's a very popular language among statisticians. But yeah, I find Python is more flexible and a bit easier to learn, I'd say.
In our team, we are doing both R and Python, but Python is much more used because the toolbox is wider, and so there is no religion. But and for people that are arriving, it's not mandatory to know Python, but it's mandatory to be able to learn fast a new language. And I discovered I discovered Python. I would say 6 years ago, or something like that. I had a strong background in C++ and on clusters with MPI. And just one day, just before leaving the academics, I tried Python. And in a few days, it was with Emmanuel. We had a code in C, in raw C, but without BLAS optimization. And I redo the code in Python, so much less line of Python. And it was, I think, 3 times faster because it used NumPy and it was optimized. And so I'm almost doing only Python now and JavaScript and C when it's really needed for optimization.
Okay. Maybe question from the audience?
Hello. My question is like how to make a transition. Like in your case, you were in astrophysics, and then you transfer your career towards as a data scientist. Then, like for example, you said you were using IDL maybe, and then you were using Python. So, I mean, then how do you, like for example, you are changing your career in a way. So how you like present yourself, like you don't have much experience using one particular tool, but your employer, how you will do it. And because yeah, that's a question. And another question is what's the difference between data analyst and data scientist? Are they the same thing or they are different things? Thank you.
Okay, so I'll answer to the first question and then we can discuss the other one. So in my case, I started doing Python before deciding to transition and to leave academia. I did 4 years of PhD and then I did 2 years of postdoc, and when I switched from PhD to postdoc, I started using Python. And at some point I realized that what I liked most in my job was doing statistics and coding, and it didn't make much sense to still be doing galaxies and cosmology and stuff and not apply it to other problems. So then I decided I wanted to go into data science. And the first thing I did was I looked into boot camps, which are, there's a lot. I don't know of any boot camp in France, unfortunately. There are many of them in Germany, in England, and a lot in the US. And basically it's like a 2 to 3 months class on data science, aimed usually specifically at people who just got their PhD in a scientific field. So I was looking at that, and I was also looking at MOOCs online to start to learn a little bit by myself. And in the end, I decided to start applying for jobs in France before applying to boot camps, and I got a job in France without the boot camp, so I skipped the boot camp part. which I kind of regret, because I think it would have given me a level field in everything, whereas now I have to pick up things on my own. But it's okay. It's one of the best ways to learn is learning by doing. So that's fine as well. One of the big problems in getting a job is convincing the person in front of you that what you did before is relevant for. So for that you have to change the language that you are using. You have to tweak a little bit things. And for example, at some point I realized that a lot of algorithms that I had been using during my PhD were actually some kind of clustering algorithms. So I didn't use them per se as machine learning algorithms, and I didn't think of them as machine learning algorithms because I didn't even know about machine learning when I was using them. But presenting them like that helped a lot in convincing people that I had a relevant experience for them. And I think, yeah, if you want to convince someone that your experience is relevant, showing that you've done MOOCs, that you've applied yourself to learning new stuff, the stuff that's missing from your background, is an excellent way. And there's also all the like Kaggle and all the competitions where you can actually show that you're capable of doing an actual project, and that's what people are looking for now.
Yeah, so I fully agree with the last part. So it's a specific example that someone coming from academia, doing a Kaggle challenge, ending up in the first 100 teams and getting a job just by showing, okay, in 2 months I learned how to do this. This is what I've done, and I think it's not a data science is not like an academic discipline per se. It's more like curious people that can learn quickly about coding, hacking, statistics, math, and that basically these types of symbiosis between the different disciplines that make the good people. And also something I've heard from people hiring data scientists, the primary quality they ask for them is to be curious and to learn fast. And this also brings me with what we've just heard, is like, when you have a PhD in, and you've done science and you know how to think in a logical way, asking questions to data and stepping back, okay, if I see this, what's the next thing that I need to ask to my data? That's what the type of the types of skills that you learn in academia and you learn in other places, of course, and that you want for your data scientists to be able to interact with the data and ask the right questions. Maybe that also answers your last part about, I'm not saying that data analysts are not doing science, but basically I see in data science also the scientific approach to asking questions and making logical decisions in the analysis. And this is something very important for people that, in the end, when you do data science, you're not solving a very well-posed problem. So you need somebody who can ask the next questions and where the logic comes in.
Another question?
Hello. It's not going to be a very difficult question, I think. Today we have two major versions of Python, Python 2 and Python 3. Personally, I'm not so much into data analysis, more into general programming, web programming. And to me it seems a very bad idea today in 2016 to still use Python 2 to start new projects. And in my personal experience with PhD students and data analysts, it seems that most of them are still using Python 2 because when you use NumPy or Pandas, it makes absolutely no difference which version of Python you use. So what's your opinion of the question, on the question? Thank you.
I could start quickly, just personally I'm switching to 3, but because there is no reason to stick with 2. but it's a matter of time, and so all projects are still in 2, but I think it's not, yeah.
Starting a project in Python 2 today is asking for trouble, because you will have to migrate to Python 3 in 2 years, and why not
yeah, yes, but for my code, the only thing I had to change is print. So, and even if you are adding a lot of things, if libraries are already, and you are not using the cutting edge properties of Python 3, it's mainly switching print to print. Pardon.
When you do statistics, please also check the decision.
Yeah, true. It's mainly that. Yeah, before I was sure that yes, but when you are doing C, C++, JavaScript, you always check the division by integers, because at some point you know that it's tricky and you have to check, because you don't remember for each language what's the. So I always check that.
Personally, I changed jobs and computers recently, so I switched to Python 3 at that point. And then I discovered that I had to use Google Cloud, and Google Cloud works in Python 2. So I have the 2 environments on my computer now.
Yeah, and I also have a Python 3 environment on my machine. I'm not going to say more. I'm staring at people in the back explaining why this is the case. But anyhow, I guess most of the code base that we have in numerics are basically the same code for 2 and 3. So in the end, all the code I write, it's using continuous integration in 2 and 3, and there's no, I agree. If I start to write a project in Python 3, I will write some code that will be compatible with both, and I will pay attention to my parentheses around the print statement, the divisions, do the necessary imports from future to make it work on the 2 environments, because I know that some people still rely on 2 because of dependencies, and especially open source library that has been developed for 10 years with millions of or tens of thousands of lines of code. And in open source, you know that the limit is not, the limit is the time of the people. So if you rely on these lines of code and nobody else is going to maintain this or rewrite everything, it's I do the effort so people can still use 2 with my code.
It was you? I'm sorry. Who was the next one? Sure? I don't know. Okay.
I was just going to follow up on that statement just quickly. Okay. There's another big difference that maybe, depending what you, for text processing, Python 3 is much better Unicode support. It's really built, it's a world of difference, like the headache you'll have with Python 2 versus Python 3. So in that area, it makes a big difference to
I agree. The only places where I have branching for 2 and 3 is when I have to play with strings. But
yeah, well, when you have to use internationalization, which in France obviously is more important than an English-speaking country, Unicode is built into Python 3 much more naturally than Python 2. So.
Hello, thanks for being here. So for fledgling data scientists or for professionals, there's a lot of different kinds of data that they might like to play with. And I'm wondering how important you think having domain knowledge about that particular kind of data they're looking at is important, and how often do you find data scientists coming from multiple disciplines?
yeah, so I can also maybe comment on this. So I tell you that a lot of students want to do data science, but in the end they need to play with signals, they need to play with images, they need to play with text. And it's true that, if you've never done any signal processing and you basically work with signals, then you don't have the basics. And it's true that, I try to push this to basically force people to also look a bit around about what is pure machine learning, because in the end, what you're going to end up using is raw data. And if you don't know about sampling theorems or things like this, and you work with signals, you're going to make mistakes. And I guess for images, there's plenty of things that you need to know. So what's an image? How does it work? How it is encoded? And plenty of things that what in the colors, or how do you work? How do you get rid of luminance problems and things like this? And this is domain knowledge. And then you need to do maybe signal or image processing to make the right decisions for your pre-processing.
I think it is also acceptable when you switch to one industry to another, you have to learn the student in your school to ask, oh, it's digital cinema projector working? Oh, okay, it's the normal learning curve when you go for a job. I'm done.
So the point was, okay, anytime you start with a new application, you have a specific understanding to have about the types of data, where's the data coming from, how does it work. That's true. Now, I mean, if you, I remember a presentation from a former Kaggle winner that was having this very provocative title, which is how to learn a Kaggle competition without understanding anything about the underlying data. Basically figure out domain knowledge just by looking at the data, which is more like the proper way of pitching what he said. But I would say in practice, especially if you don't have like humongous data where you can maybe use black box stuff, the more you understand where the data is coming from, the better you can do.
And I think it's also a huge success factor in data science projects in general. And that's also for me a problem with big data. Currently, machine learning is issuing black box results. We need to have a common language with business people, with engineer people. First of all, that domain knowledge, they have it. They have the question to ask us. And this is how it works. But we are currently unable to provide them reply they can understand. I don't know how you do, but trust me, I never use, personally I use big data for root cause analysis of problems. For analysis of root cause of problem in terms of quality. For me, it's not an option to use neural network. It's not an option to use SVM. It's only an option to use decision trees, to use regressions, because it's something that you can explain.
I don't totally agree, because I think that from my experience, I'm coming from physics, and I did some applied mathematics and data science. And first I said, all these black boxes, you don't understand what you are doing and everything. So I was quite, cautious about it. And with a few years of experience, I think it's complementary, because we are working with people in the R&D center. We are working, so we are with this machine learning algorithm. You can help some chemists or physicists to, or people from the businesses. So if you are able to talk to them and they are able to understand you because you are clear enough, you can interpret the models, so not all the models, but you can have some hints to where to look. And it's mainly, the previous example I have in mind is that you find some effects, and you put the finger on some specific points, and people will dig with their knowledge, either chemical knowledge or physical knowledge or business knowledge, and they will confirm or not. But mainly, if the work is good, they will confirm it, and they will explore and learn a lot of things, not with the machine learning tools, but a lot of things that wouldn't have been doable without this first hint and indication of where to go, how to go. That's mainly the thing that, and so sometimes just with random forest and variable importance or things like that, or it's sufficient to show the way.
It's a very common problem. Basically, you predict well, but what does it tell me about the data? And I mean, even in the academics world, there is some people trying to figure out how to interpret random forests, how to ask questions of why the model is doing this, because yes, there's a lot of business issues related to this. That's the best models in terms of performance, but then what do I explain to my clients or what I explain to my boss? And people have tried to do this with neural nets. So what is basically the best input that will capture these types of output? So there's some work along this line because it's needed for certain applications. But I guess it depends what you need to do. Sometimes if you just want to explain something, just showing a scatter plot and a 2D and a linear regression will be enough to explain, but this is not what you want to do. If you make money by predicting, then you don't want to do linear regression.
Okay. Thank you. Time for one last question.
Do you guys contribute to the open source community? And if yes, which advice could you give to young data scientists like us? And Alexandre, in particular, I know you are one of scikit-learn gurus. And what was the experience like, and what do you think about it?
If you ask me what to do to get started?
Yeah, I mean, what's your current status and how did you start? And
I mean, I would say if the best thing to learn how to do open source is to read the source code of existing packages. And I guess you're in the time where you have GitHub, and it's just so much easier to get into open source these days than it used to be 5 or 10 years ago. And I think you just learn by watching and spending time observing how the community behaves and what the people get in terms of feedback, and you understand, okay, if I had done this way, then I would get this comment, and this is the proper way to do it. And just by watching the projects, you learn a lot. It's just a matter of time, and basically try to figure out why people say this, why do they want to do it this way. There's always, or I mean, almost always a good reason, and just fetch the latest master and just look at the code and look at the pull requests, see what's going on, and if you have the energy to jump into it, just okay, say volunteer and say I wanted to work on this, and you'll get insights and instructions, and hopefully after a few weeks or even maybe months, you'll have your pull request merged.
Sorry.
Well, I don't contribute to open source project yet. I'm hoping to do it soon.
Okay, and perhaps some point of view from companies. So first, personally, I contributed to open source, but not in machine learning field, so in WebKit and MathML a few years ago. I learned a lot about programming in collaborative programming. And so it's personal digression, but for the company, I think all big companies like Saint-Gobain, it's not in their culture to contribute to open source. I hope it will change. And I think Emmanuel and me are trying to push and more in the future to do that. And from the side of people hiring, for me, candidates with some experience in open source project, it's a huge plus.